Hello, college algebra class. I'm going to give a quick lecture here on section 4.1, which is inverse functions. So we're taking a little extra time to take our test, so we're putting a lecture on in this format. I know this is going to be kind of quick, but that's okay, because in this venue you can pause me. That's fantastic. So, first of all, when we deal with inverse functions, the basic idea, we have three big ideas here. The basic idea is we're going to switch the x and y. We're going to look at the graphs of these inverse functions and how they have symmetry over the line y equals x. We're going to talk about some new vocabulary, and we're going to talk about the composition of a function and its inverse. So, let's go through some examples. First of all, anytime that you're looking for an inverse function, then the goal is to switch the x and y. Now, right now we have an f of x. We don't have a y. So the very first thing is to change out that f of x with a y. So we're going to say y is equal to 1/2 x plus 3. Now the next thing is we're going to switch their spots. It's very, very simple. Just switch x, put that in the y spot, 1/2 y plus 3. Now, the next thing that we need to do is we need to solve for the new y, and then that's going to be the f of x. So it's actually going to be the f inverse of x. So we're going to solve for y by first of all subtracting 3 from both sides. So we'll say that x minus 3 is equal to 1/2 y, and then we're going to multiply both sides by 2 to get rid of that 1/2. So 2x minus 6 is equal to y. Now when we report this, we're going to report that f, now we're going to use some notation. The new notation is the little -1 to show that we did the inverse of that function. So the inverse function of x is equal to 2x minus 6. Now let's do it again, but we need to do it this time with a parabola. So, very first thing, you change out your f of x, make it a y. Y is equal to x squared plus 4. Now we need to solve for, now we need to switch our x and y. So x is equal to y squared plus 4. Now we need to solve for the y. So x minus 4 is equal to y squared. And we're going to take the square root of both sides, but we're not going to do plus and minus this time, and we'll discuss why in just a second. So we're just going to take the square root of x minus 4, and that's equal to y. Just looking at the positive square root of that. Now we will report f inverse of x is equal to the square root of x minus 4. So that's how you're going to find an inverse, the inverse of a function. Second of all, we're going to look at the graph of f and compare it with the graph of its inverse. So we look at these graphs. I'm going to use the last two examples again and say y equals, I'm going to turn on these two graphs. We look at the graphs of these two, and you'll notice something here. We always have a symmetry, and our symmetry is always going to be about the line y is equal to x. It's going to be a line that runs right through here. So every single time you should have an axis of symmetry right through y is equal to x. So it's going to slice your graph into two parts. It should show a mirror image if you graphed correctly your f of x and your f inverse of x. Now that was the first one. That's the first set of them. We're going to make a big deal about the vocabulary in here. First of all, it's a big deal if f is a function. We defined it as a function. We call it f because it's a function. But what we're going to do with that f is we're going to say that the f of x is a function if it passes the vertical line test. Now we're also going to check and make sure that it passes a horizontal line test. That's some new vocabulary. So if you look at this initial f of x, we see how it passes the vertical line test. But it also passes a horizontal line test. Now if something passes the horizontal line test, so if f of x, it passes the vertical line test, then it's a function. But if f of x passes the horizontal line test, then its inverse is a function. So we know that when we take the horizontal line test, we know that the inverse is a function automatically. Now this is the same idea of checking f of x for the vertical line test, and then also checking f inverse of x for a vertical line test. But doing a horizontal line test and a vertical test will let you know if the function and its inverse are functions automatically. So if something like this, it passes both the vertical line test and the horizontal line test, we say that the function and its inverse are both functions. So the new vocabulary is that it is 1 to 1. Or another way we can say this is 1 to 1. So if it passes the vertical line test and the horizontal line test, then it is a 1 to 1 function. In other words, its inverse is also a function. Now this one, we can see that its inverse was automatically a function. Its inverse was also a function. Here's the function, here's its inverse, and the inverse is also a function. But notice something else. The second set that we did in our examples, we had that first parabola, but we said we only need to take the positive half of this square root. So we see that we had the parabola, that's a function, but we only took the positive half of the square root. Now the reason why is because this parabola, while it does pass the vertical line test, therefore it is a function, it does not pass the horizontal line test, which means its inverse is not a function. So when we're taking the positive side of the square root, then we're saying you're limiting it only to the part that is a function. So its inverse isn't actually a function, so we have to make a way to cause it to be a function. So what we do is instead of saying plus and minus the square root, we only say plus the square root. Now, we're still going to have that idea of symmetry over the y equals x line. It's just that not all of it's going to be nice and pretty and symmetrical. It's just going to be this first quadrant right here. But it still has a symmetry over that line. Third thing that we need to discuss is the composition of functions. So in the composition of functions, if I'm looking at f of f inverse, it's the same idea as the fog that we did before, the fog and the goff, but now we're going to take f of f inverse, and f inverse here is 2x minus 6. Now what this means is that I'm going to take this f function and replace the x with the stuff that was in the inverse, 2x minus 6. So this x was taken out and this stuff was put in its spot. Everything else is the same. Now we need to simplify this. We have 1/2 times 2x minus 1/2 times 6 plus 3. So that simplifies to x minus 3 plus 3. So f of f inverse is x. Now this is something that you're going to be proving to yourself over and over again, and your homework is that the composition of a function and its inverse will be x. It's for the same reason that we have an axis of symmetry over y is equal to x. Well, those are the major points that we need to discuss for inverse functions. I hope you've enjoyed, and make sure to do your homework because we do expect to have a quiz when we get back together on Tuesday.